Hey guys, it's Professor Tiffany Martin with Medical Microbiology, and we are in Chapter 13, which is viruses. And we have worked our way through animal viruses and talked about the same stages, that attachment and entry, synthesis, assembly, and release. So we've gone through that, but I want to go back and I want to talk about one thing that could happen, and that was the integration of DNA. So we talked about if a double-stranded DNA virus comes in, we know if it's a DNA virus, it's going to enter the animal cell and go to the nucleus, because DNA viruses work in the nucleus. It's going to go into the nucleus where the chromosomes are, and some DNA viruses will integrate into the chromosome. So there I denoted that kind of in red. My marker doesn't really show up very well. And when that happens, we call it a provirus. Now remember, we used bacteriophage. We talked about prophage when that integrates. This is a different cell, so it needs a new name, and this is called a provirus. When you have viral nucleic acid, viral DNA that has integrated into the host cell chromosome. Okay, so again, some viruses have this capability. All right, so why do we care? This one we care about because, animal viruses, they come in, we know the cell is going to be a goner eventually, but if it integrates, then it can stay. And it can stay undetected by the immune system. It's not making viral proteins. It's not doing synthesis. It's not making viral nucleic acid. It's just integrated, which means our immune system can't find it. It is hidden from the immune system, which means, weeks, months, years after the initial infection, this virus can come back. It's still being carried inside of us, and it will come back. Sometimes it comes back due to, we talked about in bacteriophage, we talked about induction, things that happen. What happens here? Usually it's as you're aging, your immune system goes down, could be stress. Let's talk about this in a case of a particular disease and look at this phenomenon. Okay, so we've got a virus that is integrated into the DNA. It is now called a provirus. It is integrated in the DNA. And when that happens, we say that this virus is latent. Now, it's not lysogenic. That is when we're talking about bacteriophage. When we're talking about animal viruses, we refer to this as latency. So if it has a provirus, then it's latency. So let's look at a particular disease such as, let's do herpes. Chickenpox works kind of the same way. Herpes. So you get exposed to herpes, carried by saliva, can be transmitted, it's infectious from person to person. It is due to a virus. It is a DNA virus. The host range, this virus, this herpes, HSV simplex virus can infect epithelial cells. So you get exposed, it infects your epithelial cells, and it's going to go through synthesis, assembly, and release. It's going to kill those epithelial cells. What's going to happen is you're going to get those cold sores, right? You get the herpes virus, you get the oral herpes, and you have that outbreak, and you get that cold sore. That's kind of distinctive physical characteristics that helps the doctor diagnose the disease. So you get that because that virus is attacking those epithelial cells. All right, so that progresses for a while, but your body's going to fight back. We do have, and we'll talk about the immune system, we do have ways to fight back against viruses. Thank goodness. So your immune system is kicked into play. Your immune system is taking care of it and is doing some things to prevent that. And so your cold sore is going to start healing. It's going to repair. Again, it can't protect cells that have already invaded, but it can protect other cells from being invaded. And then epithelial cells are constantly shedding. They're constantly being replicated and then shed, the old ones. So that's going to heal. All right, meantime, this herpes simplex virus can also infect neural cells. So it infected epithelial cells first, but then the virus, the virion, can infect nerve cells. So in that region, it will infect these nerve ganglion, but this time when it infects these, it actually integrates into the DNA. So it's going to integrate, become a provirus integrated into the nerve cell DNA. At this point, it just waits. Okay, again, it's not making proteins, it's not making nucleic acid, it's just wait. This is where that latency comes from. It's in a latent period. Your epithelial cells heal, cold sore goes away. But that virus is hiding in those neural cells, and it can stay there for days, weeks, months, years, even before you get another outbreak. So what changes? Some sort of environmental stimulus happens, some sort of change. It could be stress. Could be a change in hormone levels with stress and different types of things. It could be as you age, your immune system is not as good at keeping it suppressed and in check. But something's going to happen. So stress right before your wedding, right before a big event, something's going to happen. And then that pro-virus that's integrated in the DNA is going to excise. It's going to kill this neural cell. It's going to travel back up and then exit this cell and then reinfect epithelial cells. And so you'll get another outbreak. So you'll feel that cold sore coming back on again. And so this will actually go through a cycle. It'll affect epithelial cells for a while. Your immune system will tamp it back down, and it goes back into the neural cells and it waits. So this is those cycles that go back and forth. Now, these particular viruses that are capable of doing this are very hard to treat because you can't get rid of it. We do have some antiviral drugs. We do have some drugs that if you feel there's an outbreak coming on, and they describe it as like a tingling sensation, you can kind of feel that outbreak coming on, you can start using an antiviral drug that will help protect against cells that haven't been invaded, and maybe you can make the outbreak less. Seems like subsequent outbreaks after the first one are less intense because your immune system engages faster. But either way, because it goes back and hides in those neural cells' DNA, you can't get rid of it. So this describes diseases that have a latent period where they're so they're integrated as a pro-virus inside a specific cell. Chickenpox does this too. Same thing. You get exposed to chickenpox through contact transmission. Exposed to chickenpox, it invades these epithelial cells and causes these pox marks. And again, we're not as familiar with chickenpox because we have a vaccine for that. And so the numbers of chickenpox has greatly decreased in the last few decades. So chickenpox, you get it. You get these pox marks all over your body. Your body fights back, but chickenpox is another one that will integrate into nearby neural cells. So that will happen. So your body's fighting it, but that chickenpox virus, it's varicella zoster is the name of the virus that causes chickenpox, integrates into your nerve cell DNAs, and it goes into a latent stage. So it stays there. And this time with chickenpox, you can keep your immune system is good at keeping that virus suppressed pretty much your entire life. As you age, though, your immune system doesn't work as well. And eventually, that immune system's not going to work as well. It's not going to keep it suppressed. And at some point, it may come back. When it comes back, it travels down those neural ganglion, and it presents differently than initially. That scabs, it presents in this rash. Usually the rash is over one area of your body. It depended on which nerve cell, the neural cell that had the provirus. Not all the neural cells had proviruses in them. Whichever one had it travels back down that region, and so it will infect that area from that. And so we have because the disease presents with some different symptoms, it has a different name, and it's called shingles. This is something you get as you age. You can only get shingles if you had chickenpox first. The first time you're exposed to varicella zoster, it's chickenpox, whether you're 5 or whether you're 50 or whether you're 85. The first time you're exposed to that virus, it comes out as chickenpox. Once it integrates and then becomes a provirus, the next time it comes back out is when you get a different set of symptoms, and that's that shingles. So now, again, we have a vaccine against chickenpox, so our kids aren't getting it as much anymore. They monitor it, and they actually can give a shingles vaccine. So in those later stages, slightly different type of vaccine. It's really modified to keep that in check. It's to remind your immune system what this virus looks like, and so it can stay on guard, if you will, and keep that shingles, that varicella zoster virus repressed so that the shingles doesn't come back. Okay, so both of these are examples of viruses that go through a latent period. Anything that integrates in DNA, tough. I think we have a case study on HIV. That's another one that integrates into DNA. It targets, it actually targets your immune system. It targets the T4 cells and starts to kill those over a period of time. And that's why you can't fight off other diseases, and you end up succumbing to very simple diseases that most of the times your immune system, a healthy person, typical immune system can fight off. Okay, so read those case studies. Those are interesting. So those are coming up.